Hello everyone. Before starting this slideshow, I'd like to warn you that, for this presentation, I used artificial intelligence software to improve my pronunciation and speech in English. Indeed, speaking alone in front of a camera in a language that is not one's own can be a real challenge. But today, thanks to modern language assistance tools, it's possible to get around this obstacle quite easily. One of the main drawbacks of these tools is that they modify your voice. Let's turn off the webcam, start this short presentation, and see what it sounds like. First of all, I'd like to say how pleased and honored I am to be here with you today. I'd also like to thank you for giving me the opportunity to talk briefly about moose, one of our game animals that has always fascinated me. Before starting this show, you are certainly asking yourself, who's this guy? I have been a large animal veterinarian clinician and teacher at the Veterinary College, Université de Montréal, for more than 30 years, also veterinary trainer in several Latin American countries. Author of several articles on wildlife biology and health in outdoors magazines. Co-author of a book on moose biology and hunting. Consultant on wildlife health for Indigenous Services Canada, from 2015 to now. And, overall, a big game hunter, guide, and outdoor and wildlife enthusiast for more than 50 years. There are at least 3 main objectives of this presentation. 1. Get to know the animal better. 2. Identify the dangers it has to cope with. 3. Facilitate the identification of anomalies observed during field dressing or butchering. To do so, I am going to highlight a few original aspects of moose biology. Then I'll describe the main diseases that can affect this animal. Finally, I will say a few words about the extraordinary quality of moose meat for human health. So let's start the show. Don't be afraid, I'm not going to give you a lecture on moose biology here. No, I'll just point out a few of the characteristics that make the moose such a unique animal. Just few numbers. As you know, it is the largest wild animal that wanders through our forests. An adult male can weigh up to 1,200 pounds. Hoofprints are as big as those made by cattle. For example, a prime bull hoof width can measure more than 15 centimeters, which is nearly 6 inches. Some people say that you can recognize the tracks of a male or a female by their arrangement on the ground. I'm not sure about that, but it's worth checking out in the field. For females and young males, the bell is slender. In the case of a prime bull, it is very large and rounded. This structure is probably used to disperse odors during the rut when the male soaks it in urine and loose soil. As with all cervids, only males have antlers, and, as you know, moose antlers can be quite impressive. Develop each year from late spring to September and cast a few months later. A well-developed 6-month-old calf already has small pedicules that normally cast in March or even April. A 1.5-year-old animal has spikes or fork-type antlers, 10 to 13 inches, that have an elevated pedicle position of the root of the antlers. Cast in February or March. A 2 to 4-year-old male has small palms and pedicles that are getting lower. Cast in January or at the beginning of February. Mature bull, 5 to 12 years old. Antlers grow steadily until 10 years old, then plateau for a few years with horizontal pedicles. That cast as early as December or January. In old bull palms, they become narrow, twisted, and lower. A question often asked by inexperienced hunters is it a big calf or a small female that I see there on the other side of the lake? Yes, a small young female and a big male calf can have almost the same body mass at the end of the fall, but there are a few anatomical features that easily tell the difference. The female has a long head and nose, and the calf, on the other hand, has a triangular head. The female has a triangular white vulvar spot. The organs that sit on the left side of the animal are the left lung and the heart, the shoulder blade or scapula, the spinal cord, the brain, the trachea or the air tube, the brain artery in the neck, and finally in the abdomen, the rumen and the spleen. As you can see on this slide, the vital zone, mainly the lungs and the heart, is quite large in moose, 40 centimeters in diameter, and a shot in this zone obviously results in rapid death. Of course, a shot to the neck or head is just as deadly, but the target is much smaller and often moving. However, the areas where the animal can be injured are even larger. Indeed, a shot a little too far back is a stomach injury and a disaster. Remember that. We often hear that a hump shot is always fatal. This is wrong. There is a great risk of injury. Quite often, An animal hit in the hump will be knocked over and fall down, only to get up again fairly quickly and then flee on all fours. Same vital area location on the right. Same target, but again, a shot a little too far back can be a disaster. On this side, it is not the stomach that is going to be hit by a bad shot but the liver or the intestines. This is a deadly shot, but the wounded animal will die a few miles away, so you will lose it. Many legends circulate about the moose's senses, so, in a few words, let's set the record straight. First, vision is much less important than hearing and smell for this animal, which detects movements rather than details with his monocular vision. Monoscopic vision means that he does not see in 3 dimensions like us. Also, like many animals, moose see much better in the dark than us thanks to the presence of a reflective membrane in the back of their eyes. Moose has a much more acute and sensible hearing than humans. Can move his ears independently and even identify sound sources by echolocation. Smell is of paramount importance to the moose. It is at least 25 times more effective or potent than in humans. Also has an organ specialized in the detection of sex hormones called the vomeronasal or Jacobson apparatus. As you know, moose are herbivorous, large browsers, and ruminants with 4 stomachs. 60% of its time is spent resting and ruminating, and 40% is spent feeding and moving around. An adult eats around 25 kilograms of striped leaves a day in the summer. In winter and early spring, moose survive on fallen leaves, brush, shrubs, twigs, fir branches, and bark. His favorite leaves are willow, white birch, and mountain maple. Reproductive physiology for males and females. Rut activities from mid-September to mid-October is the mating period. The pregnancy length is 8 months, with calving at the end of May. Twins are common in healthy older cows. The calf stays with its mother at least until fall, but most of the time it spends its first winter with her. Calves are reddish-brown and weigh around 15 kg at birth. Let's talk now about moose health and diseases. Health, whether animal or human, individual or population-based, is always a question of balance between negative and positive elements. In nature, stress factors come from the environment, injuries, predators, and so on. More stressors lead to the proliferation of microbes, which in turn lead to more stressors, which in turn lead to disease. It's a vicious circle. As far as wildlife is concerned, we need to be aware that by far the biggest stressor is human activity. Of course, there are hundreds of diseases that can theoretically affect moose. But in fact, our moose are generally in good health, and only a few pathologies affect these animals on a more regular basis. Let's take a look at the main ones. The first disease I'd like to talk about is the moose winter ticks. This is really a nasty one. A real threat to the health and future of moose in our regions. Caused by a tick, Dermacentor albipictus, that affects only moose, loss of hair, anemia, loss of blood, weight loss, abnormal behavior. Those ticks can kill animals, especially young ones at the end of the winter. Let's have a look to the moose winter tick complex life cycle. In September, larvae climb onto small trees and brush and wait for a moose to come by. In October to February, nymphs feed on the host and transform into adult ticks. During February and March, adults feed on the host's blood and mate. In late March and especially in April, swollen females fall to the ground. In June, females lay their eggs on the ground. And so the annual cycle of this sad parasite continues for years to come, infecting more and more moose. Conclusion. Much more frequent in recent years due to global warming. There is now less snow on the ground in the spring and less wind in September and October. Concentrations of moose in smaller areas because of salt licks and logging operations. This tends to increase contact between animals and consequently enhance tick proliferation. Theoretically treatable livestock, in practice it is very complicated in the wild, costly, and environmentally unfriendly. The worst threat to moose population health in years to come. Now, let's see the wolf or canid tapeworm cysts, another very common pathology that you need to know. Moose is the intermediate host of 3 canine tapeworms, hydatid cysts, hard cysts, and soft cysts. Let's have a quick look at the wolf tapeworm cyst's life cycle. It starts with the wolf, the tapeworm's final host. Wolf poo is then contaminated with worm eggs. Moose is the parasite's intermediate host, and he ingests these eggs by eating leaves on the ground. The eggs develop into larvae in his intestine, which then settle comfortably in the muscles and viscera of the animal, waiting for the moose to be devoured by a hungry wolf, and then the cycle starts all over again. Hydatid cysts, echinococcus, are large cysts in the moose's liver and lungs that contain sand larvae. Only worm eggs from canine stools can infect humans. Hard cysts, Cysticercus tyrannidi, are small, white, hard cysts in the meat and heart of the contaminated moose. It is quite common. Remember, and this is important, that there is no risk for humans, and overall, the meat and offal of contaminated moose are perfectly edible. Finally, the soft cysts, Cysticercus tenuicalis, are filled with liquid with floating larvae in, either on the liver or in the abdomen. Also very common and with absolutely no risk for humans. The meat and offal are edible. Wolf tapeworms. Conclusion. Poor quality habitat and increased contact with wolves or coyotes significantly increase moose contamination with wolf tapeworm eggs. Hydatid cysts are not dangerous to humans, but dogs can be infected with larvae. People can get infected only from eggs in canine poo. In the case of hard and soft cysts, there is absolutely no risk to human health, either from eggs or even cysts, but dogs can be infected by larvae in the meat or offal. So, treat your dog against canine tetanus to prevent the contamination of deer and moose by tapeworm eggs. Finally, please don't throw away moose meat because of those little cysts. It would be a completely unnecessary waste. And now a few words about the brainworm. This parasite is very common in white-tailed deer, which show virtually no clinical signs of the disease. However, when a moose is infected, the consequences are always catastrophic, with brain damage, neurological signs, and rapid death. When there are more than 2 deer per square kilometer, the risk of moose contamination increases rapidly. The high deer population is therefore incompatible with a healthy moose population. This disease does not affect people or dogs, and sick moose meat and offal can be safely eaten. The cohabitation of deer, more than 2 deer per square km, and moose on the same territory is detrimental to the moose's health. With climate warming, we see more white-tailed deer in the north, leading to more contact between deer and moose and obviously more cases of brainworm diseases in moose. Another disease we are hearing more and more about is the chronic wasting disease. Symptoms include fever, excessive salivation, loss of coordinated movement, a bad coat, and severe weight loss. This pathology affects mainly white-tailed deer, mule deer, and elk. A few cases have been described in reindeer, and it seems very rare in moose. Chronic wasting disease is caused by a prion, which is an abnormal protein, similar to mad cow disease. It causes brain degeneration. It is a chronic condition that may take years before the animal is affected. There is always a 100% mortality rate, transmission via direct contact or contaminated soils, and the prion is highly resistant in the environment. Only a few cases were reported on a red deer farm in Quebec 2 years ago. For the moment, the situation is under control, and there have been no cases diagnosed in wild animals. So, more fear than harm for the moment. One question remains. Is the meat from these animals edible? We think so, and what's more, there's still no evidence that this disease is transmissible to humans. The risk for moose is probably lower due to the solitary nature of the species. Moreover, we can postulate that healthier habitats and, above all, a better balance between deer populations and their natural predators are essential to limiting the spread of this disease. To conclude this section, let's take a brief look at some of the pathologies you may observe in your moose. Fatty liver. Liver steatosis is a reversible condition wherein fat accumulates in the liver via the process of abnormal fat retention and utilization within liver cells. We observe this condition mainly in mature bull moose during the rut, when these animals fast for 2 to 3 weeks and need to burn their body fat in order to survive. The liver is edible but not very tasty. There is no health risk if it is consumed. Abscess or pus pockets are firm lumps of white fibrous tissue filled with thick white or green pus. They are the consequences of an injury or an infection, and animals affected usually appear healthy and may not show any signs of disease. Most abscesses are found while field dressing or butchering, and these abscesses can be found anywhere on or inside the body, in muscle or other tissue. Be very careful not to cut into an abscess because pus can spread and contaminate other parts of the carcass. Legworms, Onchocerca cervipedis, are a very common microworm that lives under the skin on the legs and ventral abdomen of the moose, forming characteristic skin nodules, photos. It is transmitted via black fly bites. Massive infections can cause hair loss and hoof issues. Moose lesions pose no risk to people or dogs, but humans can occasionally be infected following black fly bites. In those cases, very painful subcutaneous nodules are often observed in sufferers. Skin growth and warts in white-tailed deer and moose are caused by a viral infection and transmitted by direct contact. Bull moose are more often affected than females. There is absolutely no risk for people and dogs from moose lesions. Of course, there are many other abnormalities that can occasionally be observed on this animal, like overgrown hoofs or albinism, but let's say that this is enough for now. We will now turn to the last topic of this presentation, namely, moose meat and offal contamination in nutritional values. Let's start by outlining a few basic hygiene rules that you're no doubt familiar with when handling wild meat. First, do not handle or eat wild game or fowl that appeared ill before they were killed. Wash hands thoroughly with soap and water or an alcohol-based sanitizer while field dressing your moose. Thoroughly clean the carcass and especially the bullet wound. This is critical if you don't want to lose the whole carcass. Protect the carcass from flies and dirt. Cool it as quickly as possible. Store the carcass at 4 degrees Celsius for 10 to 21 days in a dry and well-ventilated place. Finally, avoid eating raw or undercooked wild meat. Wildlife cadmium contamination is not to be underestimated, especially when it comes to moose meat and offal. Few facts. Cadmium is a naturally occurring metal that is absorbed by plants, especially in the leaves. Moose ingest cadmium by grazing these leaves. The older the animal, the greater the risk of cadmium contamination. High and chronic exposure to cadmium is associated with health issues in people. There is no restriction on moose meat consumption. For the liver, you should restrict yourself to a monthly limit of 500 grams. For the kidney, the monthly limit of consumption should not be over 140 grams. Cigarette smokers, 1 to 1.5 packs per day, reach the limit even if they consume no moose liver or kidney at all. Ammunition containing lead is an important source of human and animal contamination. You need to know this because it's very important. Lead is highly toxic, especially for pregnant women and young children. Hunters should consider potential exposure risks from the consumption of lead fragments and make educated decisions to limit the chances of lead exposure. On the X-ray on the left, you can see the enormous amount of lead fragmentation in the neck of a deer shot with standard ammunition. Impressive, isn't it? Would you feed this to one of your kids? I wouldn't. Use lead-free ammunition whenever possible. Personally, I no longer use ammunition containing lead for either small game or moose and haven't for several years. Another problem that should be addressed is the probable contamination of game by defoliant agents like 2,4-D, glyphosate, and Garlin R4 used under power lines. It should be pointed out that moose rarely visit areas treated with herbicides, and defoliation forces moose to find food elsewhere. The impact of herbicides is delaying the emergence of quality moose habitat by 2 to 4 years. The most significant impact of herbicide application is a change in the distribution of moose on the territory. Since moose don't usually eat dead leaves on the ground, and 2, because these herbicides biodegrade within a few months, contamination of moose meat with these chemicals should be negligible. Be careful, though. Contaminating blueberries and black bears with those defoliants is a whole other story. Finally, let's quickly compare moose meat to beef in terms of protein, microelements, and fat. As you can see from this table, in terms of protein content, beef and moose meat are almost equivalent. On the other hand, moose meat is much richer in micronutrients, particularly iron and vitamin B12. Let's finish with a few words about fat. As shown in this table, moose meat is much less fatty than beef. In fact, it's not even comparable. What's more, the nutritional value of moose fat is much higher than that of beef. Let's take a look at it briefly and schematically. First, significantly less saturated fat. More monounsaturated fat, omega-9, in moose fat. More polyunsaturated fat, omega-6 and overall omega-3. Resulting in a much better omega-3-omega-6 ratio in moose fat. And finally, almost no trans fats in moose fat. So, really, I definitely prefer to feed my family and friends moose meat whenever I can. There's no doubt about it. There are very few transmissible or dangerous diseases in moose. Unfortunately, there are no tests available to help you make a rapid diagnosis in the field. In cases of doubt, it's best to contact a specialized laboratory. There are a few harmless abnormalities that generally do not compromise the quality of moose meat and that you should be able to identify. Moose are generally in very good health and their meat is the best food that you can eat. Finally, I'd advise you to enjoy life and, in particular, outdoor activities such as fishing and hunting, firstly to stay connected to the land and secondly to stay in good physical and mental health. I hope you have found this presentation useful. Thank you for listening, and I wish you a good day. If you have any comments or questions, please do not hesitate to contact me by email.